Hey everybody, this is Mr. Foat here coming in with a quick exponent tutorial. Making this for you guys as you're studying to be able to review this content and go over what these are, how to solve them, the different parts, as well as hopefully give you a deeper understanding of what to do when you see them. So let's dive right in. Exponents, as you can see, is a number multiplied by itself multiple times. And right away, that might not make a lot of sense to us, but let's break down the different parts first. So you'll see up here, I've got a number 3 squared. Now, this number right here, 3, is going to be our base. Right? It's our base because it's going to be the number that we are going to be using to be the number that's multiplied by itself. So that number 3 is the only number that we're going to see when we're multiplying. This little number up here, this one is called the exponent. And what it does is it shows us how many times we are going to multiply the base by itself. Simple enough, right? Well, let's dive into what that could actually look like. So let's keep using our number 3 squared. Because I know that 3 is my base and 2 is my exponent, I can rewrite this problem to something that may make a little bit more sense. So I'm going to say that this is equal to 3 times itself, 3 times 3. Remember our definition, an exponent shows a number that's multiplied by itself multiple times. So 3 squared means I'm going to have 3 multiplied by 3, 2 3s, okay? So we can do the math on that, and I can multiply. For those of you who have me in class, you may have heard me say this, but multiplication is just repeated addition, right? So what am I saying here? I'm essentially saying that I have 3 3s. So in our heads, if multiplication isn't our best part of math, we can think, okay, 3, 6, 9. Perfect. That's going to be my answer. Now, a lot of us would be able to say, okay, Mr. Foat, I get 3 times 3. That's perfectly fine. What if we get something a little bit more complex? Fair question. What if instead of 3 squared, this number could be 3 to the power of 5? Right? Well, now what are we saying? We're saying that this base number right here is multiplied by itself 5 times. How do we even set that up? What does that even look like? Let's put it up on the board here. So if this number 3 is multiplied by itself 5 times, that means that I would be expressing the idea that these 3's would be multiplied by themselves. That is something that I want to touch on real quick. Sometimes when we see exponent problems, we tend to think, oh, perfect. 3 and 3 and 3 and 3 and 3. 15, done. Not quite. Let's take a closer look. Right here, I can see that I'm multiplying each of these by itself. A common mistake when we work with exponents is we see 5 here and we think 3 times 5, 15. Not quite. What we're doing here is we're saying, all right, 3 times 3, that's going to be 9. Then I'm going to multiply that 9 by another 3. So we drop a 3 down. 9 times 3 turns into 27. Well, now what would we have to do? You guessed it, multiply that total by 3 again. So this 3, we drop down, this becomes 27 times 3. And if you're anything like me, this is when math becomes a little bit more difficult, right? You might not know 27 times 3 off the top of your head, and that's okay. With exponents, a lot of the time, it's a really good idea to set up a side equation so that you can do your work and make sure you're getting the right answer. So I know that 3 times 7 is going to be 21. 3 times 2, 6, plus the 2 is going to give us 8. So 27 times 3 is 81. However, we're still not done. This is 3 to the 5th power, which means that we need to multiply this one last and final time by 3. So this last 3 comes down. This turns into 81 times 3. On your piece of paper, you'd want to keep your work. I'm just erasing it so that I have enough board space. But I set up my equation here. 3 times 1 turns into 3. 3 times 8 is going to be 24. So this total right here shows me that when I multiply 3 times 3 times 3 times 3 times 3, I don't actually end up getting 15. I end up getting 243, a major difference. So it's really important with exponents to keep in mind that when we are multiplying, we're keeping our totals organized. Because as you can tell, it's pretty easy to get this all messed up, and that's where a lot of mistakes happen. So another way that we could potentially organize a problem like this would be, say that I have this written out right here. Well, on the side, what I can do is I can write 3 times 3. I already know that that gives me 9. And here's the trick. Instead of doing what Mr. Fote sometimes does, where we drop it down like this, you can make sure that you are doing this the correct way. We'd go, I have 1 3, I have 2 3s. Take my total, multiply it by 3. So how many 3s have I used? 3 3s. Okay? Multiply that, gives us 27. Same process. The total comes over. 27 times 3, well, now I've used what? 4 3s. Perfect. So we've already done the math here. We know that this is 81. Next thing I'm going to do is I'm going to take the total, just like before. I'm going to multiply it by 3. This is my 5th 3. We can count the amount. 1, 2, 3, 4, 5 3s, right? 5 3s. So if you're ever unsure if you're multiplying by the right amount of the base, you can set it up like this and actually underline each one of those numbers and count them to make sure that you're doing it correctly, right? We'd inevitably solve this for 243, which would be the answer of 3 to the 5th power. So I wanted to give you guys a little bit of run through of what we do when we are faced with exponents. But before we go, I want to give you a visual. One of the things that we do at Treasure Coast Classical Academy is we use Singapore math, and part of that is giving our scholars a visual representation of what it is that they're expected to do. So as we do our base number, we'll keep it at 3. I'll say that this is 3 squared. Well, visually, what is happening there? Because I can write the numbers 3 times 3, but what does that look like? Because a lot of times you'll hear this as 3 squared. Okay, let's think about it. So imagine if I had 3 units. Okay, and forgive Mr. Fote's very poor drawing. They hired me to be a math teacher, not an art teacher. And so this is why. So imagine if I have 3 bars like this, showing what? 1, 3. Well, how many 3s do I need to have? 3 3s. So let's draw another bar right here. This is another 3. And now let's draw our 3rd bar of all 3. Well, let's think about this. How many boxes, if that's what you could even call these, this is a Horrible drawing, man. So sorry. Let's count how many boxes I have, right? I have 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. If we multiply 3 times 3, we know that that equals 9. You can tell that when I put this together, I've got 3 on this side and 3 on this side. And that would be what? It'd be a square, where we get the term from. Now, eventually when we get into geometry, when you see something along the lines of like 3 cubed, that has more to do with if we're drawing 3-dimensional objects like such, right? But we're not going to get into that right away because for now, we're focused on just making sure that we know that exponents is when a number, the base, is multiplied by itself multiple times. So whenever you see that in a problem, what you can do is you can immediately break that down, just like we did, multiplying that base number by itself however many times the exponent tells you to. Hope this is helpful and hope that you all enjoy it. Have a great rest of your day. See ya.